Yep, so our first example, we have two curves running through here. And so we have then this f of x equals square root x on the top here. So this will be my f of x. And then I have my parabola on the bottom, which will be g of x. So here, we're not given a specific set of or domain that we're looking for, but we're looking for the area enclosed. And so the area enclosed will be from here to here, which will then just be those two intersection points. So I'm going to just ask you to pause the video here and see if you can come up with the area between those two curves, basically bounded by those two intersection points. Okay, so now we can see right over here that this is going to be showing up at 1. But again, we can also just set the two equations equal to each other to figure out where those boundaries are going to be. So I will actually just run through that. So root x is equal to x squared. I'll square both sides, and so this will give me x equals x to the fourth. I'll bring everything to one side, gives me x to the fourth minus x. And so 0, if I factor out the x, will be x cubed minus 1. I can set each of those to 0, and so we see that this occurs where x equals 0 and 1, which are my two boundary conditions there. So I'll come up with a new function h of x. So h of x will be my upper function, which is the root x, minus my lower function, which is then the x squared. And so there's not much I can do with that, but I will put it back into just exponent notation. So x to the 1/2 minus x squared. So I need then the antiderivative for those. Now again, I can just use the polynomial function. So 1/2 plus 1 gives me 3/2. If I divide by 3/2, that gives me 2/3. And so it'll then be x to the 3/2. And then this one here, I'll go 1/3 x cubed. Again, I have the plus c, but I'm not going to worry so much about that. My area then is going to be h of 1, which is my upper bound, minus h of 0, which is the lower bound. And so my area here, I can just put my values in. So I'll get 2/3 times 1 to the 3/2, and then minus 1/3 times 1 cubed. And again, I can see that the h of 0 is just going to be 0 overall, so I'll just subtract 0 from that one there. And so when I subtract those two, I see I have an area of 1/3.